A very good morning to all my dear students. As you all know that we are going through crucial time. Today's need is to stay at home and make ourselves safe. But we cannot deny the importance of studies also. And so we have to move towards our goal. First of all, I would like to congratulate you all for entering in standard 9th. We all are habitual of having interactive classes face to face, but I will try to make you understand and teach as I do in my class. So, me, Muskan Khatwani, your science teacher, today I am starting with the first chapter of science, that is matter in our surroundings. In this chapter, we will discuss the physical nature of matter, characteristics of particles of matter, states of matter, and how these different states are interconvertible. We will also discuss about effects of change of pressure, and along with we will discuss about evaporation and the factors affecting it, right? So you will be able to answer all the questions related to these topics when we'll be able to finish this chapter. So firstly, we will start with the definition of matter. What is matter? When I say this word matter, what comes in your mind first? What you are able to see around you this time? It might be any table, any chair, wall, cell phone, laptop. It could be anything. So, whatever you are able to see around you is a part of matter. We, human beings, we are also part of matter, right? So, if I talk about the proper definition of matter, what is matter? Anything which occupies space and has mass, that is called matter, right? So whatever is around us is occupying space. Obviously, we are also occupying space. We are also having mass. So we are also part of matter. Okay. You can give any example. It could be any animal also moving around your house. It could be any tree, any building, any mountain, any brick. It could be anything. So, according to their physical and chemical properties, now we are going to divide this. We human beings are of very curious nature, not from today, but from the earliest time. In earliest time, are made into Panch Tattva, right? And what were these Panch Tattva? Can you tell? Yes, these were air, sky, water, earth, and fire. They said everything, whatever, living, non-living, everything is made up of these 5 elements. Now we are having a modern classification with us, which is based on their physical properties and chemical nature. So here we will discuss only the physical properties, as I told you earlier, right? So what are the properties of matter? So many properties are there. Matter is made up of very small particles, right? I repeat myself, matter is made up of small particles. These particles are very small in size and they keep on moving constantly. These particles are having spaces between them. Particles of matter attract each other because of force of attraction between them. So all these properties of matter we are going to discuss and explain along with the some activities, right? So I'll start with first property of matter. Matter is made up of small particles. And for this, one activity we will do, and that is, if I put a drop of ink in water, what will happen? Yes, initially ink will be present in a small portion of water, and after some time it will spread up all over in the water, right? This happens because the tiny particles of water collide with tiny particles of water and ink will mix with each other, right? One more experiment we can do to understand this thing, that is with the pollen grains. Pollen grains, all of you must be aware, the male part of the flower, present in the flower, right? So, if we are suspending extremely small pollen grains in water, and if we'll see through the microscope, we found that the tiny particles of water do collisions with pollen grains. And due to these collisions, pollen grains start moving slightly. So what these two experiments show us, that we are having very small, very tiny particles in matter, right? Some more examples we can take to explain that particles are too small. The next example that I am taking, that is spreading of smell. All of us are aware that if I'll use the perfume, right, everybody sitting in that room will be able to smell it. When we spread that perfume, tiny particles of air will start colliding with these tiny particles of perfume, which is a liquid. So, because of the collision between these two, what will happen? Particles of perfume will start spreading in the air, and that's why we will feel the smell of the perfume. Spreading of this smell proves that matter is made up of tiny particles which keep on moving randomly. Randomly means here and there. No particular way they are having. They will keep on doing their random movement, right? One more example I can give you for this, that particles of matter are too small, too tiny, and they are having spaces between them. What I have done, if I right, filled with water, and I have made a mark on that beaker up to the level I have filled with water, right? Now I'm adding 3-4 scoops of sugar in it. Now, if I'll check the mark, what I'll be able to see? That mark of that water increases in that beaker. If I'll keep on stirring this solution, अगर मैं हिलाती रहूंगी तो क्या होगा? Finally, sugar will get dissolved in that. And after that, it comes to original mark. जहां मैंने पहले mark लगाया था, ये वापस वहीं आ जाएगा. ऐसा क्यों हुआ? Why this happened? Because the tiny particles of sugar adjust themselves in the spaces between the tiny particles of water. So, can we say now that there is a space between these particles? Because अगर नहीं होता तो sugar के particles water में जाके adjust भी नहीं हो सकते थे. Am I right? If they are going and adjusting themselves over there, that means there must be space between these particles. So we can say that matter is made up of very small, very tiny particles, and they are having spaces between these particles, right? Another example I am providing you for potassium permanganate, that is KMnO4, or you can also take copper sulfate, CuSO4, right? So what I am doing, I have taken few crystals of potassium permanganate in a beaker which is filled with water. Now what I have to do? Stir, हिलाना है इस solution को. क्या होगा अगर उस crystal को मैं पानी में stir करूंगी? I'll be able to see that crystals of KMnO4, potassium permanganate, will dissolve. And the color of the water will become dark pink. It will change to dark pink. Earlier the water was colorless and now it has turned into dark pink color. And this dark pink color is just because of these crystals of potassium permanganate. Now, if I have taken another beaker which is filled with water And now I'm putting a very small amount of dark pink solution from the first one into it. What will happen? Will this water in the second beaker will also become colored? Yes, obviously it will be. So we will be able to see that beaker which only water is present become light pink, lighter than the previous one. It will not be as dark as the previous one was, but it will be a little bit fainter, right? Now, if I have taken few more beakers with me and I'll keep on repeating this activity again and again, what I am doing? I'm taking another beaker again filled with water and put few drops of from this second beaker, around 10 ml I'm taking and putting in the third beaker. Now what will happen? Its color will change, right? But this time also the color will be a little bit fainter than the previous one. And every time it will happen. The color will become fainter, fainter and fainter. Finally, in the last one, if I have taken 7-8 beakers with me, right? In the last one, what I'll be able to see? A very faint pink color, a very light pink color. That is also not visible properly. Almost you can say that colorless solution has become colorless now. So it means that even small amount of solution contains lots of particles of potassium permanganate, or you can say that particles of potassium permanganate or KMnO4 are too small, that their small amount can also change the color of entire water, as we saw in this experiment. So similarly, we can do the same experiment with the crystals of copper sulfate also, and you will get the same result, right? It will become blue, fainter, fainter, and finally you will get the colorless solution. So what we can say from this? What this experiment proves? That the particles of matter are very small, right? So I hope both these properties of matter must be clear with you, that matter is made up of very tiny, very small particles, and they are moving constantly and having spaces between them. Now the next property of matter which we are going to discuss, that is they attract each other, right? So now for that, let's play a game. Assume that 20 students are sitting in a class, right? 20 students are there in class in front of me, and you are also one of them. I'm asking all of you to separate yourself in the group of 5. So 4 groups we will be having, right? So to the first group, I'm asking to hold each other from the back and lock their arms. Okay? So to the second group, I'm asking just to hold their hands, right? Just to hold their hands and form a human chain, simply. The third group of 5 students, they have to form each other. I'm repeating myself, they just have to touch each other. Neither they have to hold their hands, nothing they have to. They just have to touch each other only with their fingertips. And now fourth group of students should run around and try to break these human chains one by one. Okay. So what do you think? Which group will be the easiest to break? Yes, obviously the third one, right? Who are with their fingertips. Neither they have holded the hands of one another, nor they have locked their arms or holding one another from the back. So they will be the weakest, right? You will be able to break that chain very easily. So, if I consider each student as a particle of matter, then in each group the particles held each other with the maximum force, right? Can give another example for this. See, if I have given you two, three things with you, one is iron nail or chalk or rubber band, what do you think? Which one will be easier to break? And in which of these three substances do you think the particles are held together with greater force? Obviously in the iron nail, right? If I talk about water or any liquid, can we cut the surface of water? We can. We do swimming in water, right? So what we do, we cut the surface of water. We are able to do this. We are able to cut the surface of water. Why we are able to do this? Because are they not having attraction between them? They are having, but not as much as solids are having in them. And what about air? What about gases? Are they not having attraction between them? They are also having attraction between them, but not as much as solids are having. Solids are having maximum attraction each other. Liquids are having lesser than them, and the gases are having the least force of attraction between their particles, right? So all the particles of matter have force acting between them, and this force only keeps the particles together. The strength of this force of attraction varies from one kind of matter to another one. So what we discussed till now, the properties of matter, right? That they are made up of small particles, they are moving constantly, they are having spacing between them, and they attract each other because of force of attraction. How can you say that these particles are moving constantly? How can you say this? Have you heard about Brownian movement? I gave you the example of spreading the smell of perfume, right? That diffusion. Why that happened? Just because of diffusion. What is diffusion exactly? Many times we have discussed this diffusion. What is diffusion? It is the process of mixing of two substances due to Brownian motion of particles, right? So जैसे जैसे टेम्परेचर बढ़ता है ब्राउनियन मूवमेंट इंक्रीज होता है, डिफ्यूजन फास्ट होता है. व्हाट इज डिफ्यूजन? द मूवमेंट ऑफ पार्टिकल्स फ्रॉम हायर कंसंट्रेशन टू लोअर कंसंट्रेशन. मैंने एग्जाम्पल परफ्यूम का, दैट इफ आई यूज द परफ्यूम in one corner of the room, everybody sitting in the room will be able to smell, because सारे उसके जो पार्टिकल्स हैं वो एयर के पार्टिकल्स के साथ कोलाइड करेंगे और पूरे रूम में स्प्रेड हो जाएंगे. व्हाट इज दिस? डिफ्यूजन. डिफ्यूजन ऑलवेज टेक्स प्लेस फ्रॉम हायर कंसंट्रेशन टू लोअर कंसंट्रेशन. इट इज अ नेचुरल प्रोसेस. It takes place in solids, in liquids, as well as in gases. It takes place in all the three of matter, right? I hope I have made myself clear with these properties of particles of matter. So now let's move towards our next topic.